Thank you all for joining my talk today. My name is Kaxil Naik, and today I'm going to talk about what's upcoming in Airflow 2.0. But before I start the talk, let me tell you who I am and what I do. I'm an Airflow committer, PMC member, and release manager. I work at Astronomer and am part of the Airflow team who work full-time on the open source Airflow project. If you do not know about Astronomer is an Airflow company. It was founded in 2018 and Astronomer has commercial offering for Airflow. We are backed by some of the leading investors like Vanrock, Sierra Ventures, and others. 3 of the top 10 Airflow committers, including me, are either employees or advisors. We are a remote-first company, and the team is scattered around San Francisco, London, New York, Cincinnati, Hyderabad, etc. We are truly a global company. So let's get started. Here are the highlights of the upcoming Airflow 2 features: scheduler HA, Dag serialization, Dag Versioning, stable REST API, functional DAGs, official Docker image, and HelmChat, providers package, and some other notable changes. Don't worry, I'll go through all of them one by one. So the first one, high availability. Currently, Airflow Scheduler has been a bottleneck and a potential source of single point of failure. All the other components, web servers, worker, DB, can be run in a highly available manner. With AIP 15, that is the Airflow Improvement Proposal 15, we aim to make the Airflow Scheduler highly available. That is the ability to run one or more scheduler at the same time to improve performance, scalability, and resiliency. Ash, who is also an Airflow committer and PMC member, and the team and the Airflow team lead at Astronomer is currently working on it. We have gone with an active-active model, that is each scheduler does everything. For example, you would be able to run 3 schedulers and all the 3 schedulers would actively schedule tasks. If one of them dies for whatever reason, the other scheduler would keep track of the task scheduled by that scheduler. A point to note here is that there will be no leader election or any need of coordination between the schedulers like Elasticsearch does, for example. All the schedulers would interact with a metadatabase, which would be the single source of truth. We have been using row-level logs like select for update for whatever progress we have made on this API so far. I've been working with Ash to create a test suite and also measure the performance of this piece of work. We want to test it to destruction, like killing the scheduler midway, simulate a network failure for one of the scheduler and see how it behaves. This is an example configuration that shows 2 schedulers that read and write to the central metadatabase. This figure is not complete, like you won't see the broker, for example, but it is just to show the highly available environment. Like I said earlier, we have been testing the scheduler HA work with our benchmarking scripts. The key performance metric we have defined is called the scheduler lag. It is the amount of time spent when a task is not running. That is, if this number was 0, the second task would run as soon as the first task completes the execution. So it is the start date of the current task minus the maximum start date of all the direct upstream tasks. So let's say you have this one task and there are 4 or 5 upstream tasks. So the lag would be the start task of the start date of the current task minus the maximum of all the 5 upstream tasks. 0 is the goal, but we know we'll never get to 0. All the tasks we are running are echo true, like they are doing nothing but just printing true, because the actual time of the task execution does not matter. What matters is the delay between the task. Here are some results of running the benchmark for a specific scenario. Note that these results are just preliminary and subject to change. They are being currently, the whole scheduler HA work is currently being worked on and is developed in a private branch, and the work is not complete. So please, these numbers are preliminary and subject to change. Here we had 100 DAG files, 1 DAG per file, 10 tasks per DAG and 1 DAG run per DAG. With 4 auxiliary workers and parallelism of 64. The scheduler lag went from 22 minutes 22 seconds on Airflow 11010 to around 48 seconds with the scheduler HA with 3 schedulers. With one scheduler, it took around 1 minute 10 seconds. Like the total runtime for the entire all the DAGs, and the scheduler lag dropped from like 54 seconds to around 2 seconds. As you can see, the results are very promising but preliminary and subject to change. Ash has done some optimization while rewriting some pieces of scheduler, which is aiding the performance improvements. Like we were very happy to see these results, like decreasing the number from 22 minutes to 48 seconds is just something extraordinary. And that also we felt that why didn't we do this earlier? But this would land in soon. So the next thing I have been working on was DAG serialization. Currently, when you install Airflow, both the web server and the scheduler needs access to the DAG files. Both scheduler and web server parse each of the DAG files separately and create a DAG bag containing all the DAGs. As shown in the left figure, if you are using Docker to deploy Airflow and baking in the DAG files, you need to make sure that your DAG files are in sync across all the components, that is the scheduler, web server, workers. To get rid of this redundant DAG parsing and make web server consistent with the scheduler and make the web server stateless, we worked on DAG serialization, where only the scheduler parses the DAG files, serializes them in JSON format, and saves it in the Airflow metadatabase. The web server then reads the DAGs from the metadatabase, like you can see in the figure on the right. Only one component, the scheduler here, is responsible for parsing the DAG files, and the web server reads from the metadatabase, and it's just one single source of truth. This slide shows an example of how a serialized DAG looks like. Figure on the left shows an example DAG with some default arguments, a start date, and a single task called bash task. And the figure on the right is a serialized representation of the same DAG. So you can see the default args dictionary is converted into it has been annotated with type dictionary and depends on past equal to false, retries 1. And similarly, the task is serialized, where you can see all the parameters in the JSON format too. We also did some optimizations while working on the entire DAG serialization. And this optimization, like most of them, has already landed on Airflow 110.7, 8, 9, and 10, and 11. One of the important points was lazy loading of DAGs. So the web server starts with an empty DAG bag now, and only loads the DAG from the database when a user clicks on that particular DAG on the home page. The home page here shows the DAG from a different table. It shows it from the DAG table. But this lazy loading of DAGs helps reducing the web server startup time, because previously when the web server boot up, it used to parse and load all the DAGs. So if the number of DAGs is large, it would cause delays in the web server boot up time. Imagine like you having 100 or even thousands of DAG files. It would take that amount of time for the web server to boot up, and in that particular time, the web server won't be serving any request, which is bad. So this lazy loading of DAGs certainly helps. We allow users to use the JSON library of choice for serialization and deserialization. That is, you can use JSON, that is, you can use iJSON or UJSON. The default we use is the stock JSON library. DAG is refetched from the DB after 10 seconds by default. This would be from 110.12 onwards, and it's a configurable setting. So you could increase the default worker refresh interval. For those of you who don't know what worker refresh interval is, it's the time after which the GUnicorn workers in the web server are restarted. So you can increase that number to around 5 minutes, half an hour, 1 hour, 24 hours, because your workers don't need to be restarted. Previously, they used to restart the workers so that it could fetch the new DAG files, but with DAG serialization, it's no longer needed. This also paves way for DAG versioning and scheduler HA. The entire work of scheduler HA was based on serialized DAG representation. For 2.0, we plan to use serialized DAG in Scheduler 2. We are already using it for Scheduler HA work, like I said. We plan to create a separate component called a serializer or a DAG parser that would be responsible for, as the name suggests, parsing or serializing the DAG. So after the scheduler can just focus on scheduling the task which it should have done from the beginning. This should reduce the delay in scheduling tasks even further. Next is DAG versioning. The current problem is when you update your DAG by adding or removing tasks or changing task dependencies. It affects viewing the schedule. It affects viewing the structure for all the previous DAG runs. I'll show you an example soon on the graph view, on the tree view, and other views. So currently, it is also not possible to know how a DAG changed over time. For example, if you want to see that your DAG had 5 tasks before a month or so, and now it has just 2 tasks, or now the number of tasks has increased. It's not possible on the web server itself. You can, of course, look into the version control if you store them, but it's not currently possible on the web server. Checking logs for deleted tasks isn't straightforward. Let's take a look at an example that will, I'm sure, make the entire thing more clearer. Consider the DAG in the left, and when this DAG runs to completion, you'll see the figure on the right, which is the graph view that shows that the 2 tasks ran to completion. Now imagine you added a task to this existing DAG and you deployed the DAG to the DAG folder. Now, when you browse the DAG, when you browse the graph view for the same DAG run, you'll see that while this task, the new task, was not present when the DAG ran on 10th May, this new task is still seen in the DAG structure, which is wrong. You should not see it. The task was not present when the DAG ran. But the graph view shows the DAG structure incorrectly. The graph view should instead show the DAG structure of the DAG when it ran and not always show the latest DAG version. The current behavior is it would always show the latest version of the DAG. To solve this, we have proposed AIP36 about DAG versioning. We propose that we would store multiple versions of the serialized DAGs, and the hash of the serialized DAG would be its unique identifier. The DAG version badge here shows the hash, and if you click that hash, it will go to the code view. At least the idea is that if you click on the hash, it would go to the code view for that particular version of the DAG. You could see the drop down in the figure that it contains multiple versions, each will have a different hash. This will be used to identify a DAG version. We also plan to store a mixed version to show the DAG that was run. To explain it in a better way, consider a DAG with 3 tasks, A, B, and C. Task A was scheduled and run. Task B is currently running. Now you change the DAG and remove task B and C and add a new task D. Now, as soon as task B completes its execution, the scheduler would use the latest version to find the next task, and it would schedule the task D. So you have 2 versions over there, right? Version 1 that has task A, B, and C. Version 2 has task A and D. However, the scheduler actually ran task A, ran task B, and then ran task D as it was the latest version. So the DAG version is neither a version 1 or 2. So the version it ran was a mix of both the versions. So we are planning to store a mixed version internally and show that in the graph view. Note that you would still be able to see both the versions in the UI, like the figure shows two different versions, and you would be able to click on those versions to, which will then highlight the tasks that were in that particular version. So if you highlight over here on the first Dag version, it would just highlight the tasks that were in that version. The goal of Dag Versioning AIP is only to make sure that the visibility behavior is correct. We don't intend to change any execution behavior so that it remains backwards compatible. And like I said, we want to we want to keep the support for storing multiple versions of the DAG. All the views should show the correct DAG associated with DAG run and not the latest version. It is a source of big confusion and we want to avoid it. We are also planning for Airflow to have some baked in maintenance DAGs. So if you have ever used Clairvoyant DAGs, they have a good maintenance DAG. So we want to pre-bake this kind of maintenance DAGs where they run and clean up old DAG runs and associated serialized tags. So next is stable REST API. Airflow's API has been marked experimental for a long time, and that's not good for the project. We want to use APIs for lots of things, but we need a stable API. This is going to change in Airflow 2.0 with the introduction of this stable REST API. As you can see, these are the endpoints that we have thought of for the new API, and most of them have already been implemented and merged to Airflow master. So if you are interested to see, go to Airflow repo and check out the new API. Thanks to Kamil, Ephraim, and Omer who have been working on this to implement these endpoints. The new REST API is built using connection, which is Open API compliant. With connection, you build the spec first and then map all the endpoints to particular Python functions. We will have documentation on how you can migrate to the new API from the old experimental API. Also, experimental API didn't have a permission model. It was all or nothing, while the new REST API will use Flask app builder model for permission. So the idea behind that is anything a user can do in the RBAC UI, they should be able to do in the API, but they should not be able to do more than that or less than that. One of the big advantages of using an Open API compliant library like Connection is that you can automatically generate clients for different languages. The tool shown in the slide, Open API Generator, can be used to generate client libraries in Python, Scala, Java, Go. One of the committers has already started working on a Go client using this tool. And we also have repos for Python client, JavaScript, and Java. So that's one of the biggest benefits of using Open API compliant library. Next is functional DAGs. This was one of the feature that most of the Airflow Summit attendees were very excited to hear. And if you haven't watched the Airflow Summit videos, watch the talk of Gerard from Twitter, who gave an awesome talk about functional DAGs. So what was the problem we were trying to solve? Currently, there is no explicit way of passing data between tasks except XCOM. XCOM exists, but is a source of confusion for new users because they need to learn XCOM pull and XCOM push syntaxes to just transfer data between tasks. Even if you use data pushed by the last task, you still have to explicitly set the task dependencies between them, or else it would result in a value not found error. The other problem with XCOM is it is useful to pass small amounts of data. The current limit on the XCOM, if I remember correctly, is 48 kilobytes, which is not more. It's good if you want to pass some metadata like number of rows in the table or column names in the table, some task IDs and etc. But not useful if you want to transform a pandas data frame or something like that. Check this example. This is a normal way of writing DAX at present. The task load uses the data pushed by the transform task. However, you still need to define explicit dependencies between them. You can see the last line in the diagram, which shows extract needs to run before transform, which needs to run before load. The whole question is, why do you need to set the dependencies when you know that the load task is depending on the data pushed by transform task, and the transform task is dependent on the data pushed from the extract task, but we still need to push it, at least in right now. Also, there's too much boilerplate code to read data from previous tasks using XCOM. The next slide I'm going to show is will be the new functional way of doing things. So look at those, compare those tags. These are exactly the same tags. This one is written in a functional way, the other one is written in the normal way. Check how easy it is to return multiple values from a function. Under the hood, all these values are pushed to XCOM, but the user don't need to worry about it. You can also pass argument to your function. Previously, you need to use op.args and op.quargs in Python operator, whereas with new op.args and op.quargs in Python operator, whereas with new functional DAGs, you could pass it in a more Pythonic way. The task or dag.task operator, like the decorator, converts a Python function into a task using the Python operator. And you no longer need to explicitly define task dependencies. Like if you consume value from a task, a dependency is implicitly set. Like here you can't see those bit shift operator that says extract, transform, and load, because that is done under the hood for you. Also, using dag.task assigns that particular task to a DAG. It's simple code, makes it more readable, makes it more Pythonic, and you don't need to worry about the XCOM syntaxes. You will also have a pluggable XCOM storage backend, so you could store XCOM data in S3 or Google Cloud Storage, allowing users to transform big chunks of data between tasks. So you can store a data frame in a CSV file, or you can store data frame in a different format in S3, and the next task can load from S3 or cloud storage. And as you have already seen, it improves readability, dependencies are automatically set, and all this is backwards compatible with Airflow 110. A big thanks again to Gerard from Twitter, like I said, folks from DataVent, and Tomek from Polydia, who worked on this API. This is going to make it very easy for the people, for the new users. Next one is the official Docker image and HelmChat. Our users have been asking for an official Docker image and HelmChat from a long time. Previously, Puckle's Docker image was quite popular, and thanks to Puckle for creating that. Alpha quality image was available since Airflow 110.10, so that was not long ago. I think since the beginning of this year, if I am not wrong. After some more iterations and feedback from the community, beta quality images have been available since Airflow 110.11, which is like a few weeks back. You can get the images from the Apache Airflow repo in Docker Hub. Just run docker pull Apache Airflow to get the latest image. We support Python 2.7, 3.5, 6, 3.7, 3.8, but please Please, if you're using Python 2.7, stop using it and upgrade to at least Python 3.6. I'll tell you at the end of the talk why I'm saying this, but please, I cannot stress this more. The size of this image is 210 MB compressed, and we are using Python Slim Buster images as the base images. There are lots of customization options. You can choose a different base image. You can install a different version of Airflow from pip, install from GitHub, install extra Python dependencies or system dependencies and other things. You can find the entire list of options at this particular link. Go to Airflow repo and find images.rst. That would have all the information on which arguments you can pass. Coming to the HelmChat. So this was donated by Astronomer. Astronomer uses this HelmChat for all its deployments. It's beta tested and used by hundreds of production deployments run by Astronomer. It now uses the official Airflow Docker image. Currently, it's also used in the Airflow CI to run Kubernetes test. Check the Airflow repo and open the charts directory to find more details about the HelmChat. It supports KEDA. If you have not heard about it, it's like Kubernetes-based event-driven auto-scaling. So you can say scale the number of salary workers if you are running more than 16 tasks or more than 30 tasks or for a defined number of tasks. Also, the HelmChat supports all executors and has several options to mount decks. One thing I forgot to mention was if you're interested about KEDA, check the Airflow Summit video of Daniel Imberman, who is my colleague at Astronomer. He has talked about how to use KEDA and how to leverage KEDA, so you will get benefits of both worlds, like Celery and Kubernetes. Okay, there are several options to mount decks. You can use like git sync sidecar without persistence from a PVC. There are liveness probes that reset the components on failure, like the scheduler will be restarted on heartbeat failure. The screenshot over there or the commands over there are just how you can start using the HelmChat. Just clone the Airflow repo, go to charts directory, create the Airflow namespace, and do some Helm dependencies update and Helm install Airflow. And also let us know if you have any feedback about it. If you want something included or something like that, please feel free to let us know on the mailing list or just contact me on Slack and we can take it from there. Next is providers packages. So as part of API 21, all the contents or hooks, operators, sensors, secrets from Airflow contrib directory were grouped and moved in providers directory. Previously, everything was inside Airflow operators or Airflow hooks directory or Airflow contrib when Airflow was donated by Airbnb to ASF, the Apache Software Foundation. Grouping them allows us to, in future, separate all these providers into separate repos. Each of them can have their own maintainers, can be released separately. So that was one of the main motivation to group them and move into a providers package. Like example over there would be, you can see the AWS Athena operator and AWS SQS operator. They were moved under provider Amazon AWS directory. Similarly, all Google Cloud operators, hooks, and everything were moved under providers Google, and then cloud. So some might also ask, like, why Amazon and then AWS, or why Google and then cloud directories are separate? This was because, like, Amazon has many services other than AWS, and Google has many other services other than cloud. So this would allow adding like Google marketing, Google AdSense, and something different in a different directory. We have also created a backport packages from this provider directory in Airflow master by automatically refactoring them to make them compatible with Airflow greater than 1.10.6 versions. And this is so that the users can start using the latest hooks and operators without waiting for Airflow 2.0. Because what happened was people were contributing the hooks and operators, but they were not being released because Airflow master has moved a lot from Airflow 1.10 versions. So this would help the users to get the latest hooks, operators, even the secrets packages. If you don't know about secrets, please check. I'm not going to cover that here, but please go and check and read about secrets, secret management. Coming back to backport packages, like 58 packages were released, but note that they would only work with Python 3.6 and above. They are released separately compared to Airflow. We don't release it with the stock Airflow package. As in, the backport packages have a different cadence compared to the Airflow package. Right now, we have just released 58 packages in one release, but I think now we are going to release it on ad hoc basis. Like if someone finds an issue in the Spark hook or operator, we'll fix it up and we'll release it individually. We'll not release Microsoft or Google operators at the same time. Also, that is one of the benefits of the providers packages and backport packages. Now that we already covered the major changes, and there are also some other small but still important notable changes, which are Airflow now only supports Python 3 or will support only Python 3 from Airflow 2.0. We have already dropped support for Python 2.7 in the master branch, and that is why I was saying and laughing when I said, if you are using Python 2, please stop using it. It has reached the end of its life on 1st Jan 2020. So please migrate to Python 3.6 and above. RBAC UI is now the only UI. RBAC UI, like, it has a role-based access control, and it's based on Flask App Builder. The old Flask admin-based UI has been deprecated and removed from master and won't be available in Airflow 2.0. You could start using RBAC UI by adding a config called RBAC equal to true under the web server section of your airflow.cfg. Subtags have been improved. Currently in Airflow less than 1.10.11, the task used by subtag operator are run as a backfill job and has some known issues when it comes to honoring full limitations. This has been fixed in Airflow Master and would be released as part of 2.0. We are also considering if we just make all the entire concept of subtags just UI only. Currently the discussion is going on the mailing list, but that has not been, we have not come to a conclusion basically. CLI has been refactored. Commands are now grouped functionally and logically, and on Airflow on Airflow 1.10 series, you have commands like Airflow create user, Airflow list users, Airflow delete users. They have all been grouped into Airflow users command, and that would have subcommands like Airflow users create, list, or delete. That makes more sense, right? And it's easy. So, road to Airflow 2.0. We've talked about these awesome features. How are we going to reach 2.0 and when are we going to release it? Like, this is one of the favorite questions and people are waiting to hear the answer for this. When will Airflow 2.0 be available? So currently we are planning to release Airflow 2 in the last quarter of this year. I'm going to post on Airflow dev mailing list on how we are going to do this. We are planning for 15-day calls, developer calls, to align on the scope and then see how we are progressing towards 2.0. But definitely we are going to release it this year. And stay tuned. Stay tuned on the mailing list and Airflow Twitter. So even if we release 2.0, the important question would be how would the companies upgrade to 2.0, because it's going to be a big jump. So this is what we suggest. Install the latest 110 release, run Airflow upgrade check command. So again, this command has not been implemented yet. We are planning to create this command, like that issue work in progress PR is already there. We are planning to create some rules that would help. That would be like Python 223, Py 223 script that would say, okay, you need to refactor this. If you say yes, it would refactor it automatically. But you will be able to see all the changes that command will make. It would also show any warnings if it's not like automatically replaceable. In that case, it would just show warnings which you will have to fix it manually, and then of course upgrade Airflow. So this section, links and references, contains some details on the topics I talked about today. All the talks from the recently concluded Airflow Summit are available on YouTube. So if you're more interested in one like Airflow Scheduler HA or the functional DAGs or something like that, go and check the videos over there. You'll get a lot more information over there. Also, there are Airflow improvement proposals, AIP 15, 21, 24, 32, 36, and there are a lot more. Go and have a look at them if you'd like to know more details about them. And if you like to get in touch with me, follow or contact me on Twitter and LinkedIn, and join Airflow Slack if you haven't already. And that's it. Thank you. Time for Q&A.